Let's solve problem 2.15 for Microelectronic Circuits 8th edition by Sedra and Smith. Using this circuit and assuming an ideal op-amp, design an inverting amplifier with a gain of 20 dB, having the largest possible input resistance under the constraint of having to use resistors no larger than 100 kiloohms. So the input resistance is just the resistance connected between the input voltage source and the input terminal, which is the negative terminal in this scenario. So Rn is just going to be equal to R1. Now, if you're not familiar, the gain in dB is just another expression for evaluating how much gain an amplifier produces. Yeah, we can convert that gain back to volt per volt by just using this expression, 20 log 10 times the absolute value of the gain in volt to volt. So in other words, 26 dB is equal to 20 log base 10 of the absolute value of G. So we can say 26 divided by 20 is equal to log base 10 of G. I can get rid of that log by raising both sides to the power, or setting it as exponents with the base of 10. So I get the absolute value of G is equal to 10 to the power of 26 divided by 20. Plug into my calculator, we get about 20 volt per volt. Now, is this gain actually positive? The answer is no. Because the voltage input is at the negative terminal, this is an inverting op-amp. And the whole point of an inverting op-amp is to amplify and negate the input voltage. So therefore, our actual gain is negative 20 volt to volt. Now, I can use this, negative 20 volt to volt, to set up an expression for my resistors, because the gain in volt to volt is equal to negative R2 divided by R1. So let's solve for R2. R2 is going to be equal to 20 R1. And we see the constraint that resistors can be no larger than 100 kiloohms. And I know my R2 is going to be greater than R1 because my gain is greater than 1. Well, the absolute value is greater than 1. So given these constraints, we'll go ahead and make R2 equal to 100 kiloohms, which means R1 is equal to R2 divided by 20, which is equal to 100 kiloohms divided by 20. That should be 5 kiloohms. And as I mentioned at the start, Rn is just equal to R1. So Rn is equal to 5 kiloohms. And that's the problem.